So I did get an interesting question in the break about whether or not you can cheat on the ladder with this, and the simple answer is pretty much no. As I was explaining, part of the problem with the API sometimes is that the functionality doesn't exactly match the real game, and that's because it seems to have been applied as a layer on top of the game. So it sort of doesn't really allow that direct interaction with the game. It's only through that layer. How you create a game and join a game is all done through that layer. So you just can't join the ladder with a bot. So that's how they kind of prevent it. So, you know, your rankings are safe for now. So let's get into actions. So this is kind of the last big piece. Fairly important, but actually mostly fairly straightforward. So it's not really as dense as the state and the observation space stuff, but there are a few variations that we can go through. So the first action you may want to do is move the camera. Up the top here is how you get the camera location. You may recognize a little bit of that code where we get the camera using the categorical layer. So 1 means it's got a camera there and 0 means it doesn't. I've done something a little bit different here where I take the y coordinates and I get the average or the mean. And the same with the x coordinates. And what that'll do is give me the center of the camera. So that's kind of your x, y coordinates of where your camera is. And then you can get the camera size by subtracting the min from the max, and that'll give you the height or the width of the camera. Now, I generally work with a square camera, so you only really have to do this once. You don't have to do it for the x and the y, but you can actually have non-square resolutions, so you would have to do the same thing for the x coordinates. And then setting the camera position is really simple. Every action you perform goes through actions.functions.something, in this case move camera, and you feed it a tuple of x, y. So if you're not familiar with Python code, these parentheses here, that means it's a tuple. Of course, you need 2 of them in order to feed that tuple into a function. And that's pretty much it, and it'll send it there. There is kind of a strange quirk that had me caught up for a while. There's kind of a rounding error problem or something weird that happens. The camera position you feed in, if it's say 10, 10, if you use the code up the top to get the center via that method, might come out as like 11, 10 or 9, 11 or something else. So if you want to move the camera back to that position and you're like, oh, it's not 10, 10, I'll move it back. Oh, it's not 10, 10, I'll move it back. It'll just sit there moving the camera. So don't expect it to feed you the same value back out that you fed into it. Also be aware that the x and y coordinates have to be within the minimap size. So if you've got a minimap resolution of 64, which is the default, the values have to be between 0 and 63. So don't feed a 64 in, it'll explode. And the top left up here is 0, 0. So that's fairly straightforward. The observation and actions are kind of the same in that regard. The thing here is you feed in x and y. When you get the observations out, it's y and x. So you have to spin everything around. Selecting idle workers, it kind of happens a lot, especially if you're Terran and you go and place a building. That worker will just stand there once it's finished. And then you've got an idle worker. This is how you select it. Pretty straightforward, select idle worker. You do have to feed in this select variable. Now that actually represents a range of select actions. They become a little bit more important for other type of select actions, but they generalized it so you can use the same thing for selecting idle workers. What kind of gets a little bit weird, as soon as you select an idle worker, your screen will move to center on that worker. So it kind of threw me off at first. I was like, why is my screen moving? I didn't move the camera. I selected an idle worker. It moves your screen. So you're going to have to move your screen back if you want to have all your relative positioning and that sort of stuff working out. And then the other thing here is you can also do select all. So you can select all of your idle workers. And so if you want to select all the idle ones and put them back on minerals, you can do that quite easily. I'll talk about minerals in a bit. Building a barracks. So you selected a worker, now you can build a barracks. here's where the available actions comes into it. And there's a kind of subtle but pretty important difference. You can see in the actions.functions.buildBarracks screen called down the bottom, it's just buildBarracks screen. But if you want to check if the action is available, you have to put .id on the end. So it's kind of subtle, but a lot of people will feed in if actions.functions.buildBarracks screen in obs.observation.available actions, and it will never be true. You have to feed that .id in, otherwise it will never work. Now, building the barracks on the screen, the first parameter here is either now or queued. So if you've got an SCV and you want to build 2 barracks with that SCV, you can actually queue up the building of those barracks, or you can queue up moving it somewhere, or making it attack something, or making it go back to minerals. So once again, they've generalized that concept of queued or not queued across all these actions. And then, of course, the X and Y coordinates for the screen. Once again, have to be between 0 and, say, screen resolution by default is 84, so between 0 and 83. One tip, you can help your agent by preventing it from building in the mineral line. That's pretty important because if you choose a random location, it tends to build in the mineral line a lot, and that's really annoying. And it tends to not be able to learn very well when it puts a barracks right in the middle of the mineral line and slows down the mining. So you can actually do, most people who've done any algorithms courses, there's actually an algorithm that you can get the outside of your command center, the Vespene and all the minerals, and then it'll give you the coordinates for that. And then you can check if the location you're about to build is in there, and if so, choose a different location. It's actually a fairly simple algorithm. I think you can use scikit. I think it's got something in there for that. So it'll give you a polygon, and you can just say, it even gives you a method to check if the point is within there. So that lets you sort of eliminate those problems pretty quickly. And then if you've got a Protoss or a Zerg agent, you can help it by telling it that it needs to build on power, where there's power, or for Zerg, that it needs to build on creep. Otherwise, it'll just keep trying. And then, unless you're feeding it the creep locations and it's able to relate the location it chose with that creep, it may not be able to learn the difference between it shouldn't have built there and it should have been able to build there. So, just one of those little quirks. So I kind of mentioned this earlier, but you should look out for where you place your buildings, because they become invisible and become more difficult to interact with. It's a lot easier for your agent to manage its base if it doesn't have to move the screen around. That's another level of complexity that I don't want to deal with. I put around a 5 to 10% buffer around the left, the top, and the right. And I'll put about a 20 to 30% buffer along the bottom. You may want to experiment with that, because sometimes depending on the map, you'll find that it'll place it just there, and then it can't see it. So fiddle around with those numbers and sort of crop the values that it can choose if you're letting it choose a random location. This is an autocast. I kind of put this in there to show how you can do an effect or an auto-casting effect. Once again, you do have to check if the action is available, but then there's no arguments here because it's a simple action. Just do it. You don't have to queue it. You don't have to give it any coordinates, so it's fairly straightforward. Harvesting minerals. This is interesting. So yes, you have to check if the action's available, but then you kind of want to choose some minerals. Except there's like 12 or something different mineral types that you have to check for, and they change depending on the new maps and the new types and the updates. So I've kind of got this little constant in here called mineral unit types. But you kind of saw this before when we selected our marines. You can find all of the minerals on the screen, the mineral units on the screen, just by checking if they're in the mineral unit types array. You don't have to check if they're neutral units, because mineral types are always neutral. Then you do want to check if you get more than 0 minerals. Otherwise, if you try and gather to a mineral location that doesn't exist, the rest of your code, when you do this random choice, will break. So get your mineral units, maybe pick one at random or choose one, depending on your bot, and then just tell it to go and gather it at the mineral X and Y coordinates. And in this case here, I've shown you how you can do a queued action instead of an immediate action. So you could send it to build a barracks, and then you could send it back to the minerals. Strangely though, I haven't had a lot of success with that. So it might be a bug, it might be my programming, but you've got to sort of play around with that and just see what works and what doesn't. So here are the mineral unit types, just in case that wasn't confusing. Yeah, there seem to be certain mineral types that are designed just for specific maps, and then they become quite popular. So, and this list will change, guaranteed in the future. They will add and remove, maybe not remove, but they'll definitely add something. And here's your Vespene types. Thankfully there's only 6, but same thing. They've kind of, see Shakuris, they've designed a Vespene geyser just for that map. So just be aware of that. It's not always going to be Vespene geyser. The bottom one there, if you try and choose that, there won't be any on a lot of maps. So now selecting the barracks. So we've kind of done the same thing here that we did with Marines. We're getting all the barracks that are on the screen that belong to me. Once again, we have to check that there are some. We choose a random one, and then we do select point. And the first argument here, you can do a simple select like we did before, but we can also do this select all type. So that's basically like control clicking on barracks that'll select all the barracks that are on the screen. Remember again, click the coordinates between 0 and 83. And for the grammar police in the audience, I know a barrack is not a singular of barracks, but I didn't want to mess around with barracks or anything like that. Setting a rally point, just really to give you an example of another type of action. Once again, check if it's available, and in this case, give it the now. So you can give it a queued action, but I don't know why you would. It's just because it's a screen action, you have to give it now. So this is one of those examples where they just designed it to be generic and it sort of fits. And then give the X and Y coordinates. You can change units to workers and rally your workers. And you can use a minimap instead of a screen, which might be a little bit tricky if you're rallying workers. You don't know where they're going to end up. Control groups. These are kind of a unique kind of concept. They've got their own distinct set of parameters. Simple select control group. Now that's a little bit deceiving because selecting the control group may not select the control group. It might add them to the control group, which is kind of what we're doing here. So yes, you can use set, which will put the units into the control group and remove anything that was there. You can use a append like we have here, and you can use recall, which is actually selecting the control group. So a bit of a misnomer there, but it's not too hard to deal with. And I have had issues with control groups as well. Surprise, surprise. They don't seem to always work. So who knows, maybe there'll be a new patch and it'll be fine. Training Marine. So in this case I'm training Marine, but it's the same for any unit. It's called train. Even if you're training a Zergling, which doesn't make a lot of sense, well, that's what you're doing. You're training a Zergling, you're training any type of unit. Once again, check the type, and then you can queue it, but it doesn't really make sense, so you generally just do it now. I have noticed some bugs, again. If you've got 2 barracks selected and you train a bunch of Marines, it does seem that the first barracks will fill up, and then the second barracks will start getting Marines queued up in it. Whereas what you do normally in the game is you train several Marines and they'll put one on one barracks and one on the other, and then one on the other barracks and then one on the other. So they distribute more evenly. And I sort of feel like that's a pretty important thing to not have working, but it's one of those things that hasn't been fixed yet. Because if your bot isn't learning that it can distribute more evenly, it kind of gets caught having to manage the training queues a little bit differently. There is also a really strange thing which I have to confirm in a bit more detail. When you have multiple units selected, all of those units sometimes will do the action, even if it's not the kind of thing that you want them all to do. So if you select all your SCVs and you say build a supply depot here, as a human, When you do that, it will move one SCV and build that supply depot. And you can actually queue them, and then it will send a different one to the second one and a different one to the third one. When you do it through the API, I haven't really tested in a lot of detail, but sometimes it'll send all of them to build a supply depot at that place, which is not really what I want. So a little bit quirky, to see how that works for you. How I get around that is I just select one at random and then tell it to go and do it, and I select a different one. Upgrading to orbital command. This is here just as an example of a morph. Zerg is probably the main race where you would understand a morph. Zerglings become banelings. Pretty much every other Zerg unit becomes something else if you morph it. You know, there's some of those sorts of things around. In the case of Terran though, you can upgrade your command center to an orbital command by doing a morph. And this particular action is a quick type. So you don't have to tell it where on the screen or where on the mini-map or anything like that. It'll just do it, but you do have to tell it now or queue. Now, scan is an example of an effect. Effects can be things like scans, but they can also be like spellcasting. So if you do a side storm or something like that, that can be an effect. So there's two ways to, I guess, cause an effect. One is on the screen, one is on the minimap. Straightforward, but I just thought I'd show that as a, that's another type of thing that you might want to look out for when you're looking at the possible actions and you're like, how do I do a storm? Well, it's called an effect. Building a tech lab. This kind of only applies to Terran because none of the other races really have add-ons as a concept. It looks pretty straightforward, right? It's just a quick action. You just build a tech lab, right? However, there's kind of a bug built in at the moment where when you do tech lab quick, it actually thinks it's supposed to be a screen action. So you're supposed to give it X and Y coordinates so you can build a tech lab over there. So what you have to do in this case, if you do this, it'll actually lift your barracks. And it will actually require coordinates. So you have to lift your barracks yourself anyway. That's what I found is the easiest thing to do. And then if you call build tech lab screen with coordinates, it'll go and land the barracks there and put the tech lab on it. Same with the reactor. It's probably handy to do that anyway, because if your barracks is too close to another building and it couldn't put a tech lab there, it will lift in the game anyway. That's what it's designed to do. So I find lifting it and then choosing a location kind of works anyway. And that kind of brings me into this concept of action grouping, because this is the reason that bug kind of exists. By default, common actions are grouped. So the best example is Zerg. There are more, like say stimming for Terran, Marines and Marauders, both stim. With Zerg, many of their units burrow. Pretty much every ground unit can burrow. But instead of having to say, hey Zergling, burrow, and hey Hydralisk, burrow, you just say burrow, and then it issues the Zergling burrow and the Hydralisk burrow. So that's how it groups it together, and that's kind of where some of the quirks come into it. So there's actually a list of actions in the actions.py file, and they have two arguments. If they've got the second argument, that means they're grouped into another argument. And this is kind of where that comes in with the building the tech lab. But for the most part, it's generally fine. You can disable this by changing hide specific actions equals false in your agent interface. And that means you can act on specific actions. It still doesn't fix the bug, by the way, but there may be cases where you want to do one and not the other. Maybe you want to borrow all your Zerglings and not all of your Hydras. Research, another pretty important thing that you're going to do quite often. Although the guys at DeepMind tell me you don't actually need to research any upgrades in order to do quite well. And in fact, they say you can pretty much be up to almost the hardest level without upgrades. So there's something going on there. This is how you do it. Pretty easy. Research whatever it is, and it's a quick command, same as the other ones. However, this is probably the biggest hole in the game or in the API right now. there's no build queue for upgrades. There's a build queue for units, but there's no build queue for upgrades. So once you say upgrade this, let's say weapons level 1, that's it. You don't know anything else. Like, you have no idea whether it's started, whether it's finished, nothing. So there's a few ways you can get around it, and none of them are necessarily foolproof. One that I have done is I know how long an upgrade takes to build, and then I select the building again and go, okay, is that upgrade available? No. Okay, have I got enough money to build it? Yes. Okay, maybe it worked because I said that it should work. But there are little cases where that doesn't happen because maybe that building got destroyed and then you rebuilt it. So it's not necessarily guaranteed. There is a little bit of some changes that are there in the feature layer, in the feature units layer, that does have a build queue number. And so potentially you could say build this, and it would say, okay, your build queue is 1. It won't tell you what's in the queue, but it will tell you that there's a build queue of 1. So that might be a little bit more exact, but I'm going to work on some improvements hopefully soon that will make this stuff a little bit easier to track. Stim, this is just another example of an effect that we talked about before, except this is applying on a unit, like on an army unit level instead of a building level. Same kind of thing, pretty straightforward. And then probably the most important one you're ever going to use, attack. Once again, you can use the minimap, you can use the screen to attack. And this command, you can just change the word attack to move, and it'll move the units around. So that's pretty much the most common thing that your bot will be doing. So there's some tips around this because actions are probably one of the trickiest parts. Consider scripted action sequences. So what this means is when your bot starts out and you give it basic actions like click, select, you have to give it maybe all the coordinates on the screen that it can select, which is 84 by 84 possible things that it can click on. And then just by chance, it happens to click on the barracks. Then it has to, just by chance, choose to build a marine. So you can bring those together and say, let's make our own action called build marine that finds a barracks, clicks on it, and builds a marine. Or recalls a barracks control group and builds a marine. It makes it a little bit simpler. You're reducing the action space considerably and making it more concrete that your bot produces the outcome that you're expecting. Consider scripted building locations. That's really just to stop it randomly placing stuff all around and trying to place on terrain that it can't place it on. So you want it to sort of be predictable as possible when you're starting out. So if it can't build there, don't ask it to build there. It doesn't know the difference between success and failure. It has to kind of learn that, and then it has to understand why. If you're simplifying the state and you don't provide it with that information, it's never going to learn why. So it's just a little bit easier to just say, here's where you can build these buildings, go for it. Consider scripted build orders, or at least the idea of limiting how many buildings of a particular type it can build. There's not a whole lot of point in having 10 engineering bays. You kind of only need 1, maybe you need 2, but you don't need 10. So it doesn't need to go down the whole road of exploring, well, what happens if I build 10 engineering bays? So, okay, you get 1. You build 1 engineering bay, that's what you get. Potentially build orders could make it a little bit simpler. If you want your bot to focus on attacking and you want to train it for attacking, give it a scripted build order. Okay, I'll go supply depot, barracks, I'll pump out marines. When I've got enough, I'll build another barracks, and when I need more supply, I'm going to add more supply. And then it doesn't have to guess any of that sort of stuff. It's just looking around the minimap or around the screen and saying, what do I need to attack? Then, attacking is simply if you choose the closest enemy location. I won't go into it in too much detail here, but I am going to write a tutorial about this. There are some tools built into PySC2 that you can look at all the coordinates of the enemy and find out which one is closer. Now, if you do any sort of coordinate mapping stuff, you should be able to figure that sort of stuff out fairly easily. And then if you just choose the one that's closest to your base, that's actually a pretty good attack method. The only thing that trips that up is when you've got an overseer that just flies around your base. That kind of messes with my agent a little bit because it goes, oh, I'm going to attack that overseer, and the overseer is really fast. So it brings all the units back to my base, and then the overseer buzzes off again. And then it's like, okay, I'll go attack over there, and then it buzzes through the base, and then it comes back again. And, so there are little things like that. Maybe you can get around that by looking at the screen where you're going to attack and going, oh, it's an overseer, forget about it, let's attack somewhere else. And that actually works quite well. Consider automated supply management. What I mean by that is when you need more supply, build a supply depot automatically or build an overlord automatically, whatever it takes. So maybe not when you hit 0 free supply, but maybe when you've only got 5 free supply or something like that. Have it automatically script in to add more supply so your bot doesn't have to deal with learning that it needs to add supply. And consider automated worker management. This is mostly important for Protoss and Terran, but once you go and build a building, your workers just stand there. So the best thing you can do to sort of simplify it for your bot is if there's an idle worker, send it back to minerals. The same thing applies for balancing between minerals and gas. If you want to have 3 on gas, just make it so if there's less than 3, it goes and puts 1 on gas. And then if you've got 16 workers on minerals, and when it goes red over your command center and it says 16 of 10, then maybe you send those workers to a different base automatically. So if you can add that stuff in, it's one less thing that your bot has to learn. It is kind of cheating a little bit, but it's really up to you to decide whether that's something you want to learn or whether you're playing with something else that's maybe a little bit more specific. This is an important one that the DeepMind guys kind of brought up when I went to the conference last year. Try limiting the actions to those that are valid in the current state. There's no point trying to attack. If you think about 84 by 84 attack coordinates, and by the way, you don't have any army units, then it's going to try and explore that whole vector. Okay, let's go down and try to attack when you've got nothing to attack with. So yes, you can attack with workers, but maybe you want to limit it so it only tries to attack if it has army units. And I found that's kind of pretty handy. There's this thing that kind of happens where when you've got those 84 by 84 and you can attack, you can select. There's also a rectangle select. And then you've got all the possible other things you can do. Something like do nothing, or which is actually a pretty important thing for a bot to do sometimes, or maybe build a marine. Build a marine is one action, but attack can be hundreds or thousands of possible actions if you've got one for every coordinate. So the chances of it finding that build marine action is a lot smaller, so it has to explore a lot more games, run through a lot more games to go, actually none of those attack things worked, now I'm going to use the build marine. So if you limit, it and exclude those things, it's going to stumble across build marine a lot more often and probably be a lot more successful. The one trick there is you want to limit, if you're limiting the actions, you want to exclude them when you're learning. So the concept with Q tables is you take the maximum value in the state that you land in, the maximum value for all of the actions. So if you have a look here, the first row there, the maximum is 0.0, and so the grayed out action on the right there maybe isn't possible. But when you have Q tables, the maximum will be 0.0. If you exclude that action that you can't do, the maximum is minus 0.1, which is actually far more important because you're like, hang on, I don't want to land in this state anymore. That was a bad thing to do. Instead of, it's kind of neutral. Didn't really matter, which is what's going to happen if it's 0. So yeah, I don't know what that bottom one means. But I think what I'm saying there with the bottom is these two kind of equate to the same thing, even though one actually has a negative reward and one doesn't.
And it's 0 because you initialize
it. With Q tables, you initialize to 0. So that's why it's like that. Now, it depends on your algorithm and what you're doing as to how successful that's going to be. This is another trick. When you simplify the state, you're going to have places where the state doesn't change. You took an action, and the state looks exactly the same. Maybe the time continued, but the state didn't change. Maybe you don't include the time in your state. So what you want to do is potentially don't learn from that action, because what it tends to do is take any values that are negative or 0 and bring them upwards to your highest value. Because it learns from, in the case of Q tables, it learns from the maximum reward for that state. So you can see the top there might be the state before it takes the action. And then say it chooses action 0, it lands in the same state, and maybe with a discounted reward it goes, ah, cool, that was a good thing to do. Probably not, because it didn't really change anything in terms of what your agent saw, but it landed in the same state and it increased that reward for an action that should have really potentially resulted in nothing. In the second example, the bottom example, it took the negative action, it landed in the same state, and that negative action became less negative, which is not really what you wanted either, because it didn't actually produce a less negative result. It kind of produced the same result. So to play around with this one, the one trick here is sometimes the second last state and the last state can be the same. And if you don't learn, when it hits to a -1 or a 1, then you've completely wasted that whole game. So if it's the last state, then learn from it regardless. It's kind of one little thing that caught me out, and I had hundreds of games going along, and then like a third or half of them were completely thrown away because it just happened like the last state and the second last state were the same. Yeah, that's kind of a waste of several days of training. So this last piece is fairly short, the reward. There's not a whole lot to it, but when you get to that last step in the game, you will get a reward. So if obs.last, if it's the last step in the game, the reward is obs.reward. That's it. You can feed that in to your network and say, that's a -1, it's a 1. Now you can use obs.reward in all your intermediate states as well. That's what you tend to do because it's going to be 0. But that's how you get it. Now generally in the last state, you're then going to train your agent and say this is the last step. If your algorithm needs to know that it was the last step, save all your stuff out because nothing worse than losing hours of training. And then because there's nothing left to do, just return a null. That means you do nothing. You have to return an action, so that's the default. Which is kind of another trick I didn't really put in here, but it's kind of good to fall back to doing a null walk if everything else didn't work. If you couldn't choose anything else, just fall back to doing a null walk. So that's usually the last line of my step method is always return null walk. So some little tips for rewards. You can define your own reward structure. You don't have to use what they give you. You don't have to use sparse rewards. You don't have to use the 1 and the -1. You can use 100. You can use -100. And in fact, reward structure is one of those things that nobody's really figured out yet. What is good and what's bad. It's kind of up to you to explore and play around with that. Be careful what you reward because you just might get it. There's a good lesson I learned early on where I rewarded my agent for killing the enemy. So every time there were less enemy units, it would get a point. The problem is that then it tended to sit outside the enemy base and wait for it to produce units. And it just waited, and then killed it, yep, killed it. And I was like, that was pretty good. And it never moved in and took out all the buildings and finished it off. So you have to be really careful with your reward structure. Now, that kind of leads me into another idea, which is you might actually split your agent up and reward different parts of your agent for different actions. If you have a part of your agent that is designed to build units, so you want to just pump out Marines as quickly as possible, give it a reward for pumping out a Marine, and it'll manage your supply and it'll manage your number of barracks and all that sort of stuff for you. If you have one that's rewarded just for killing units, well, when there's enemy on the screen and you want to make sure you kill the enemy, give it a reward for killing enemy units, a -1, +1. And then there's kind of when you've got the fog of war on, there's one that's kind of pretty cool, which is finding the enemy. And this is kind of the one that I've had the most fun with, because it you kind of just need a very simple network to say, where is the enemy most likely to be at this point in the game? It's a little bit tricky because it could depend on all the battles you've had up to that point. You might have had a full base trade and completely swapped bases. And so at that point, things are completely different. And quite often with the AI, you'll go and destroy their main base. You'll run off somewhere else and go look for their other base. And then the main base they go and start it back up again. Even though it's got no minerals or anything, they go, oh, let's go back up here and build some stuff here again. So that's kind of a cool one that I've kind of been playing around with for a while. So here are a few limitations, and these are based on questions that I get all the time. Can you accept surrender? The answer is no. It's the first thing that happens, because when you play against very easy, as soon as you send a marine into the enemy base, it pretty much surrenders. Like it says, oh no, I'm scared. And so you can't accept that surrender. So you have to play the game out to completion. You have to kill it. There's no way to accept surrender. It is a pretty interesting point though, because how many times do players win games by their enemy GGing and saying, come out? And maybe it's a bit like poker. Maybe it was just a bluff. Maybe they thought they were in a worse position than they were, or maybe they were right. So there is a theory that being able to accept surrender might actually be just as good as actually destroying your enemy. As we kind of mentioned, it's really hard to track upgrades. It's really, really hard. And you know, you can click on your units. Hopefully, when I get around to it, make it so the API you can click on your units and actually see what the upgrades are. But at the moment, you can't really see it. So that's one of those things you kind of have to keep track of in the background somewhere, somehow. It's very difficult, and that's kind of why I struggled to get my bot to be any better than what it is. Kind of related to that, there's no research progress, so that's another thing we want to kind of get in there, figure out, well, where's our research at? Are we 50% complete on researching Stim, or where are we at? There's no ghosted buildings, so that's pretty common. People want to know, well, I told her to build a barracks here, is it going to be able to do that? Right now there's no ghosted buildings. It is something that the DeepMind guys have said they want to do. It should be possible. There is actually data in the API that gives you that information, but it's really about how do you pull that information out and present it in a way that makes sense. And one of the trickiest parts to that is the entire API or the entire PySC2 structure is built around a single layer. So everything can be flattened and fed into a neural net. But if you have ghosted buildings and you have 3 or 4 or 5 or 6 or whatever, and you have a build queue for a unit and the SCV is going to build those, it kind of can get multi-dimensional, and so that may not feed into that single structure as well. So that's one of those tricky things when you've got a fixed number of features that you're feeding in, and they can vary and have substructures and stuff like that. So I believe that's kind of one of the things that's getting in the road of getting that to work. There's no build queue and multi-select. This really annoys me because when you've got 2 barracks and you've got units queued up at both of those barracks, you don't know how many they've got when you've got multi-select. So how do you know that you can add more? How do you know you've got 3 out of 5 and you can add 2 more? How do you know that you've got 5 out of 5 and you shouldn't try and add more? That's something that maybe is going to be possible. There's some information in there, and I'm going to work on trying to extract that information and make it available. This last one is also pretty common. There is an alerts observation and there is a last actions observation, and I haven't been able to get them to really do much of anything. And the word is they're pretty unreliable. So normally you would get an alert when you're being attacked. It's not really that reliable. Normally you get some feedback when you took an action to say you can't put your building there. It's not really that reliable. I'm thinking that's probably the thing they're working on the most to make sure that information is fed back in, and hopefully that'll be a lot better. And a few other questions I tend to get. Can you play against your bot? Yes. Yes, you can. It's kind of tricky because the API is designed to run at the fastest possible speed, not at real-time speed. So there is a real-time mode, and yes, you can be one of the players and you can play against your bot. That's kind of cool to do. You won't be able to use the same sort of full game, but it's kind of cool. Does it support supervised learning? Yes. The tricky part is if you've modified your agent and you've limited the state and you've limited the actions, then when you click around on the screen and do things as you would in a normal game, it may not fit into the normal structure. For example, you may go click on the barracks and then build a marine. But it might be a few steps apart. Whereas the bot will select the barracks and build a marine immediately in sequence. So you're better off interacting with the game for supervised learning through an interface that supports the actions that your agent has. So if action number 3 is build a marine, you have to type in number 3. And there are ways to do that. You can receive input at each state. It gets kind of tedious because usually you have to make it stop. You can make it sort of run on the fly, but once again, it runs really fast. So you've got to put it to real-time mode and all that sort of stuff. However, it has been, I've done it, it's been quite successful because all you do is pump out like 20 marines and then send them across and you can pretty much win every time, and it does learn. And the third question is, can it process replays? Yes. The same problem kind of applies. If you've limited the actions, then it can be very difficult to translate the replay actions into the actions that your agent can actually perform. There's also this thing where multiple actions can actually be performed in one step in the real game. So when a pro player clicks around really fast and does a bunch of things really fast, sometimes some of those actions get grouped together into a single step. And then how does your agent learn from that when it can only take one action? So there's kind of some quirks there. However, a couple of days ago, DeepMind were at BlizzCon, and most of their progress that they've made in the last year, or a big piece of the progress they've made in the last year, was processing a bunch of replays so that it can learn what some of the strategies are. And there's actually a huge number of replays that Blizzard has provided that you can feed it. Like, it's gigs and gigs and gigs of replays. I don't know how, it's got to be millions. So if you do want to process replays, it can do it. You just got to figure out how to make that work for your bot. One other issue, Windows versus Linux. Linux is used by DeepMind, so they test that all the time. So it's going to be probably the most rigid. However, I use Windows all the time, and I haven't really had any problems running it. In fact, they've had a few more Linux issues than I've had on Windows. One of the problems with Linux is it lags behind. So because they have to go and modify the game and actually release a Linux-specific version for this, they tend to lag behind quite a bit. So you won't get the latest balance patches, and some of the latest maps won't work because they don't have the little piece of the code that they need. Linux bugs, based on the same idea that they've got to do a special release, Linux bugs take longer to get fixed. So there are bugs in there that they've been waiting on for quite a while, and they don't have a huge development team, so they do take longer to get fixed. So you kind of have to live with what you've got sometimes. Windows, on the other hand, stays updated. It's the official game. It's the game everyone's got, so it stays up to date, 100%. But because PySC2 lags behind because of Linux, sometimes you can't do all the latest things that you want to do. I get around this by coding little patches into PySC2 myself. So I put the latest ladder maps in there, and then I submit that for review by DeepMind, and they go, oh, we can't play this map because it has some little thing in it that our Linux version can't handle. So they just remove that line and remove that map. So I'll go and put it back in my local version. So you just got to be aware of that. Sometimes there are going to be limitations and things that you can't work around. Lastly, a couple more resources. The top one here is the Discord, the StarCraft2 AI Discord. It's very, 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 very active. There's not a huge number of people, but they're very active people in there. In that Discord chat, there's every single StarCraft2 API language framework. The guys from Blizzard and DeepMind are in there quite often. The bot builders, the guys who build their stuff on C++ and some of the other languages, they put their stuff in there. They run their stuff on Twitch all the time. They announce it all in there. So if you want to get into the scene, get onto that Discord chat. And then, of course, I'll go in there and answer questions all the time as well. And since this was a lot of information to try and throw at you, and not all of it sort of soaked in necessarily, or maybe you didn't know how to piece it all together, this is the latest tutorial I did for the latest version of PySC2. You build a Zerg bot, not a Terran bot, because I wanted to do something different. And it steps you all the way through from the beginning to giving it some machine learning, and you've got a bot that actually does stuff. So that's kind of cool. So that's it.